A couple of quick announcements. I did create this additional resources module inside your Canvas class. One, it has a link to the textbook. I think I had it in another module earlier, but I just kind of created this one and put it up at the top. And then aside from my lecture videos, because not in this class particularly, but in a couple of my other online classes, I've been getting messages like, basically my videos are not enough for them to be able to finish their homework. And they're like, well, what do I do? And so you do have options, right? One, you could be going to the tutoring lab across the way. Two, you could be reading the ebook and seeing if that gives you any more insight as to what's happening in the sections. Three, the Cengage themselves actually has videos. And so I posted their videos in here. Now they're links. So when you click on this, it happened to be in the Excel file. That was what they did. I didn't do this. And then what you do is, like, once you find the section that you need, you basically just copy and paste that URL and it'll take you to the lecture video for that section, okay? And it's not just each section. I don't like it like this. I'm gonna actually click on it to download it because I can't see, that's way too tiny for me. But if you actually click on the file, it'll download and it's much easier to view. See, this is much easier for me to see. So like, even though section one, chapter 1, section 1, they have one video here. They apparently don't have a video on chapter 1, section 2. We don't even do chapter 1, so it's not that big of a deal. But you do see, you do have some extra videos in there for particular sections. Okay, so it's not everything, but it's something. I'm also downloading the PowerPoint slides. So they do give instructors PowerPoint slides and they say, hey, you know, if you don't got nothing to work with, use these and you can kind of give your classes like that, right? I don't use them. I just have my own way of doing things sometimes. And so I created my own videos to mimic that. But I am going to put those PowerPoint slides that they had recommended that instructors use, okay? Right now it's downloading and it's telling me that it's gonna take a whole day to download it right now. I don't think it's gonna take that long. I think eventually, I closed everything down and just left it like that when I left my office this morning. But you will see another resource in here, and it'll be the PowerPoint presentations, okay? So you can look at those as well. You could always Google anything, right? If you look at the titles of the sections, when you look at the WebAssign links, they tell you exactly what the content is in that particular section. So you could just Google or YouTube search those titles, and I'm sure you'll find gobs and gobs of people explaining the same thing in a different way, okay? And then if you find like a particular person that you like, you could just always just follow their subscription, okay? Okay, so today we're gonna be working on the review. Now I did see that somebody submitted it. You can submit it over and over and over as many times as you want. It is for a grade, so I would highly recommend that you go in there and keep working at it until you get 100, right? Just so that it's there and saved and you have that recorded as your grade for your review. Reviews are 10% of our grade in the class, okay? And I made them 10%, one, because it's a whole letter grade. It's a nice 100 because you can keep working on it and working on it and working on it until you get that 100, okay? It's the same with the homework assignments. You can keep working on those over and over and over again. But were there any people that maybe didn't submit it, but at least like looked at it and identified some problems that they were worried about? Because if you do have some that you're worried about, those are going to be the first ones that I covered. You can click on it now and look at it if you want to. I think for you, you have like begin, please, or something like that. But not for me, I have to click preview. Go ahead. It is right here at the bottom of the instructions. I have online students that do that to me. They click on it and then they email me, I need an access code. And I'm like, well, did you read the directions? Yes, I did. Are you sure? Because like, how do you miss that? It's funny. Like people tell on themselves all the time. I don't even know. Okay. Let me click preview just so I can see what you see. And I do mention a bunch of stuff. This is pretty much like the same kind of instructions that you'll see on the test. Like you do have to work out the problems by hand. You do need to explain where you're coming up with your answers. If you're doing stuff in your head, you need to write down what it is you're doing in your head, okay? I can't read your mind, so I don't know how you're going from A to Z, and I need to know that in order to be able to assess whether or not you know what you're doing, right? So you definitely have to show your work. Calculators are going to be allowed, but they're only going to be scientific calculators or even a basic calculator, but definitely no graphing calculators are allowed. Okay? And so basically anything that you could type in here is totally allowed. Okay, this calculators are not going to do anything that's not allowed. Okay, so these are the formulas that you'll have, and it's exactly like this. If you were to take the test in the computer, it would look exactly like this. And then eventually your test questions would be below that. And you'd have to scroll up and down to see your note sheet or whatever. But if you're taking the test in class, then these will be printed out for you. And so you'll have them on printed sheets next to you when you take the test. Okay. Now this said like refer to figure something or another, which is why I scratched it out. There wasn't nothing, no magic statement in there. It just said refer to figure something, and I don't even have a figure on there. So I just erased that little figure comment. But this should be everything that you need. I mean, it talks about existence, it talks about definitions of limits, some basic properties, more elaborate properties, more properties, right? Lots and lots and lots. It's just a lot of limits, lots and lots and lots of limits. Oh, and Ruben, I don't know if you saw it, but I remember you had asked me that one question about why sine of x over x was 1, and it wasn't, I was thinking of a different proof with cosine, not the one with sine over x. So when I was trying to do it, it wasn't applying because what I was doing was supposed to apply for a similar one with cosine. So I did search it, and then I was like, oh, duh, that's the long one that I never like. So what I do is I put it in here in week 2. Where is it? There it is. I put why the limit of sine of x over x is 1 when x approaches 0. And it's just a YouTube link to some guy who like goes through all the areas of the triangle and explains why this area is inside that area and all that good stuff. And so they prove it. So if you're curious, you can go check it. Oh, you did? Okay, good. Sure. I just didn't want to come in class and then spend all the time explaining that again, because it is a little lengthy. Okay, so does anybody want to cover a particular problem from the review? And you do have, I guess this thing times you because I want you to practice with time constraints. But here you have 120 minutes to do 15 problems. And then when we do the test, you're going to have about an hour. It says an hour to do 10 problems, but really it's 9 problems because the last question is like, how well do you think you did on the test? Do you think you got an A? Do you think you got a B? Do you think you got a C? Be honest, okay? It's not really a test question, right? That one's pretty easy to answer. But there's 9 actual math questions on the test, okay? And I won't tell you which ones they're similar to. Like, did I already give you a hint? Go ahead. Yeah. Those are the 2. Those are always the 2. Yes. Mm-hmm.
But it says be sure to explain your answer.
Mm-hmm. Oh no, it does say that. Let me go.
Yeah.
Dun, 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 dun.
It's like on almost every question.
Oh yes, that is. Oh, and I think I mentioned it up here actually. Where do I mention it? Oh, I don't even think I say it. But anyway, I guess I'll say it out loud. But these are just so that you can see what the instructions are going to look like when you take the test.
Oh.
So you don't have to turn in any paperwork or anything like that for the review. You don't need to explain anything to me, but Those are the exact kind of directions that you would see if this problem were on the test, okay? So all the things that it's asking you to make sure that you show, those are the things that I would want you to be showing when you take the test. Now, if you do all the work on paper and you want me to look at it and tell you, yay, this is enough, or no, I need more here or there, you can just take pictures with your phone and then text it to me, and I can look over it and examine and make sure that all your explanations are adequate, okay? But you can do that. Okay, you said intermediate value theorem, which is this one. Now, this is the annoying ones because you have to type them in, and there's no way to get around that. It's gonna take a little bit to type them in. I'm thinking I put 90 minutes on the thing, but anyway. So it says use the intermediate value theorem to prove that this thing equal to 0 has a solution between -4 and -3. So the first thing you have to do is you have to identify the function that you're referring to, and then the y value that you're referring to, that you want this function to equal, okay? And because they gave us an equation, they literally gave us both of those bits of information, right? So you just say let f of x equal, and then I'm going to click on these little triple dots, okay? And then I'm going to hit this little square root button. It says insert math equation when I gloss over it. And then this kind of gives me a template to type whatever I want in there. And if you can help me, because this thing blocked, I can't move it. And it just blocked what I was doing. Here, let me do this. Maybe that'll help. Yay, there we go. So then I'm gonna enter 3x raised to the 3. What is it? Plus 9x raised to the 2, get down, minus 3x plus 5. So that's going to be my function. I said let f of x equal this, and let, they say k, but it really doesn't matter what letter you use. And what number is it going to be? What number is on the other side of the equal sign? 0. So my k is 0. Then we need to do the 2 criterions that would have to be met. One is that my function must be continuous on that little interval that they gave me from -4 to -3. And then 2, my y values need to be y values around the 0. Because the y value, which is represented by k, because that k value is 0, then that would make sense if I got to be around 0 on both ends of it. One of those y values has to be positive, right? And then one of them would have to be negative in order for me to end up with y values around 0, okay? So that's essentially what you're looking for here. So we're gonna go ahead and try to show first criterion first. Since f of x is a polynomial function, it is continuous. You can say everywhere or on infinity to infinity, but I find it easier to type in the word everywhere than an interval, -infinity to infinity. Therefore, I'll say f of x is continuous on bracket -4, -3 bracket. So that's my first criterion, it's met, right? Just because of the fact of the way polynomials work, it is continuous automatically. So if it's continuous on the whole thing, then it's certainly continuous on just that little interval, okay? Then the second criteria is to show that when I plug in -4 for x, and when I plug in -3 for x, that my y values, one will be positive, one will be negative, hence around the k value 0. Okay, so we'll do f of -4, and then we'll do f of -3. Now this part you don't have to type out, you can just put it in your calculator. So if I do 3 parentheses -4 to the 3rd, get down, plus 9 -4 to the 2nd, minus 3 times -4, plus 5. I get the value -31. Confirm with me if you do have your calculator, because sometimes I type things in wrong. what do they call that? Like fat finger syndrome. I have it. I just always push the wrong buttons. My text messages look pretty good. Okay, I got 14 for this one. Did you guys get the same? I'm gonna turn off the front lights because I see it's struggling trying to see this. And then this might help too. Let's see. Control plus plus plus. Yay. Big, right? Did it go away? Oh no, it's up here. That would have not been good. Oops. And then all you have to do is say the second condition, which is that, which one's the smallest y value? The k value, which is the y value, the -31 or the 14, which one's the smallest? Say it again. -31. So I'm gonna say that this guy, because that's what -31 represents, right? Is less than your k, which is 0, and then is less than the other guy, which is +14, which is f of -3. This is all you needed to show, was that this criterion was true, okay? Now remember what I told you, if you plugged it in and the top one happened to be positive and the bottom one happened to be negative, then your labels would have to go the other way around, right? Because f of -3 would be the guy with the positive, with the negative, and then f of -4 would be the guy with the positive y value. So just put them wherever they belong. If your k is 0, put whichever one that is a negative on the side, and then whichever one that is a positive on the side. Does that make sense? Now that you've met your criteria, you just say, therefore, according to the, and I don't even write it out, I just say IVT. I know that that means intermediate value theorem. There exists an X value such that f of x equals k. And what does that mean? That means if you're saying that there exists an X value such that f of x equals k, isn't that saying that there exists an X value such that this equals this? Because this is f of x, is it not? And this is k. So if you're telling me that the intermediate value theorem says that if the next value exists that makes that equation true, then that you have shown me that there's a solution there. Now I'm lazy. I'm not going to write the whole function again. So I'm just going to say f of x equals k. If you wanted to be more elaborate, you would such that this thing. But you're on crunch time too. So I only wrote like what is necessary, nothing extra. And I said values, not values, right? Good, good, good. I'm glad you brought that one up. That's a good one. So we did number 14. Any other ones anyone wants to see? About this one, are you all awesome at that one? Do you remember these? I had to do one in class, but I was like way long time ago, right? Feels like it anyway. Y'all want to see that one? It's a big one. I was I was gonna make you do it because it is a big one. But this one I do have to write on paper before I can actually write it on the computer. Because I'm not gonna write everything in the computer. Ideally, I'm not gonna write my scratch work on the computer. I will write the actual proof on the computer, but not my scratch work, okay? So let me minimize this and open my camera. Okay, so we've got this one. And according to that epsilon delta definition, you basically have to show that this implies this. Okay, that's what you want to show. And I think for back in my proofing classes, we would just abbreviate that with WTS. That's what you want to show. I haven't done it yet. That's just what the goal is. Okay. So I want to make my want to show statement more specific to all the numbers and the functions that I have. Okay. So I'm going to make it very specific. So in mine, what is C? It's 1, right? It's this guy, the guy I'm approaching. So that's the C. And then my f of x, what is that? 2x minus 5, then subtract symbol. And then what is my L? -3. And you could put in parentheses. I'm gonna make it turn to a plus in a minute anyway. Okay. Now remember, I'm only writing my side work down. This is not my proof. I will type the proof in the computer. I am going to mess with this more complicated piece and try to make it look like this side. Because if I do, then I'll have an expression on how to write delta in terms of epsilon. Okay. So I'm going to start with this weirder side, and I'm going to change that to a plus. Then I'm going to combine my like terms. And remember what the goal is. The goal is to make the inside of those bars look like this. So what do you think I need to do to make that look like this? Factor out the 2. It's getting closer, right? But I want the 2 outside the bars, right? So you have to actually separate it into its own because it was in bars. So it still needs to be in bars until you decide it's not necessary to have the bars. What is the absolute value of 2? Just 2. And so then in order for me to get these bars all by themselves, what do I need to do? And so then that's gone, and I have those bars all by themselves, and now I have an expression in terms of epsilon on the right-hand side, right? But what's supposed to be on that side is delta, isn't it? Okay, so then basically you have your proof. You're just going to start the proof with, for every delta, there's going to be an epsilon that goes with it. It's just the epsilon, half of the epsilon, right? And that's it. So when I go to my proof, anybody still writing this? No, got it down? Okay, I'm gonna go from this screen to the big one. So you're gonna start your proof with let, and I gotta get that delta in there. So I'm gonna do my triple dots and this little equation thing. And then notice there's a tab here that says Greek. So I'm gonna hit my Greek tab, and there's my delta equals epsilon over 2. And I just hit the fraction bar on my calculator, on the little number pad on the keyboard, and it automatically made a little fraction. I didn't do anything crazy. I just clicked epsilon and then hit the fraction on my keyboard and then calculate it. That's what you need to start. Okay. And then from here, remember, you got to start with shift. No, not shift. Where is it? Oh, okay. Above your enter key, you see on your keypad, there's like a backslash, and then there's like something that kind of looks like a long colon, right? But it actually brings up an absolute value bar if you hit shift and then hit that button. So instead of going to that keypad, I just do shift and then that button above the enter key. Then it opens up a bar. X minus 1, close it. And then my less than symbol, I'm gonna need another delta because I have to start with that, okay? So I have to start with this. And then from here, I'm supposed to show that somehow that magically turns into f of x minus L, less than epsilon, okay? I'm gonna go back to my screen. What I'm trying to show is that this statement, after all my manipulation, will look like this statement, okay? And I have all the steps because all I have to do is go backwards, okay? So I'm gonna be looking at this page a lot. Oh, I might as well just live in here. So I need arrows, a double arrow. This means implies, okay? So if I have that, since delta equals epsilon over 2, Greek epsilon over 2, I'm just replacing my delta with epsilon over 2, right? Then the next thing I'm going to do, since on my paper I had divided by 2, I'm going to do the opposite, which is to multiply by 2. So arrows implies bar x minus 1. Oh, I forgot to do times 2. 2 times. And less than 2 times epsilon. So all I've done is multiplied by 2, right? I haven't changed anything. The statement should still be equivalent. And some people just do it all one thing. They just keep going and going and going. I don't, but it's totally okay if you do. So then my next step is to put it in bars so that I could stick it inside the other bars, right? So we're gonna have this 2 in bars now. And then what's 2 times epsilon over 2? Just epsilon. So this side, oh, because I didn't write it in there, that's why. This guy, oh, come on. There we go. That's what it was supposed to look like. Right? Isn't that what was over here? And then I multiplied both sides by 2, so it should be like that. And then those 2 should cancel, and I should have just my epsilon. But now that the 2's in bars, I can go ahead and stick it inside the bars. So I'm gonna do 2 parentheses x minus 1, close parentheses, the bar less than epsilon. And it should look like that. Oh, why is there an extra bar? There it goes. And then we'll distribute our 2 and then basically split up that last number. So if I distribute the 2, I'm going to have 2x minus 2 less than epsilon. And here's what I meant. I could just keep going. I could just say implies bars 2x. Now, how did it split up that 2? It was minus 5 plus 3. And then in order for me to get the right format, they wrote it as 2x minus 5 minus a negative 3. Why does it keep putting that little thing in? I don't know. I told you I have that fat finger thing where it just keeps, I don't mean to push. So you could have done this, you could have just arrow, 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 all in one line if you wanted while you were in the test box. And it'll just look like this, and then you just go to the next line. You could just type it all over. You don't have to keep typing and going back to this and going back. But I did distribute my 2, and I got that. I split up the -2 into this, and I only knew to do that because of what I had on my paper, right? And then we also knew that this actually needed to be minus that -3 because that's what L is. To be f of x minus L. But I'm done. I have proven that this statement essentially, with all the algebra, that's in a six. And that was the specific thing that I was trying to prove, right? Let me show you back on my camera. So this was the general thing I was trying to prove, but this is the specific thing that I was trying to prove with the limit statement that I was given, okay? Does anybody have any questions about that one? So if you're taking the paper test, of course you don't have to type nothing, right? Nowhere, you just write it. But when you do write it on your paper, make sure that you put your side work and it's labeled side work and then say proof and then write down all your proof, okay? Okay, those are the big ones. Is there any other ones in here that you want to see? Oh, let's do these graph ones. Those are like super visual. They should be really fast, okay? So anybody know what the answer is here for number 1? What is the limit of this graph as x approaches the x value -1? What is it? 0.5? Let's see, how are these going? 1, 2, 3, 4 to get to 1? Yeah, so each one's like a quarter, and 2 quarters, you're right, is going to be 0.5. Now, it does not tell me whether to write a fraction or a decimal, so I'm just going to put 0.5. If you put 1/2, I'm pretty sure it accepts both of them, or even just 0.5. I think I entered all 3 of those as possible answers. But yeah, you're right. The key thing here was to pay attention to those increments, right? Not just say, oh, it's a second mark, so the answer is 2. Okay. And you also got that this is the actual limit. This just happens to be where it's actually defined, right? It's different. They didn't ask you what is f of x. If they asked you for what was f of x, it would be this y value, -1. That's not what they asked. They asked what is the limit of f of x, okay? Okay, what about this one? Why does it not exist, this one? Say it again. There's a break in the graph, right? It's on the, let me get my arm right. On the left side is going to negative, right? But then on the right side, positive. And in order for the regular limit, no plus or minuses to exist, they have to go to this place. Okay? And since they're going to 2 different places, this one would be D and E. Good. Now, what about these? Just looking at this, I know it says all of that up there, but is the answer going to be a D and E at all? No, right? I mentioned that one side of it. Right? That's a one-sided limit, and they always exist. Okay? Even if they're infinity or negative infinity, they always exist. So what is Because it does say that you have to type in your answers respectively. So you do have to give me the answer to this one first, then put a comma and then give me the answer to that. Okay? On your paper, you're just gonna explain like the y value going to this as x approaches -1 to that. So what y value am I going to as x approaches -1 to that? And here I am, and my y value is -2. Comma, and then what about as I approach -1 from the right? What is the y value? If you type them in backwards, the computer will tell you they're wrong. I would go back and tell you that they're correct, but I might deduct a point because you didn't follow directions, right? But 9 points is better than 1 point, right? Okay. Not for limits. We don't care if it's defined there or not. Because that's a limit. If I was asking you what is the actual y value when x is -1, then yes, it would follow that. Okay? But I never asked you what is f of -1. I just said where's it going as it goes to -1. Okay, but good question. What about this one? I'm approaching 0, but from the right side, right? So when I follow it from the right, going towards 0, it goes down, 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 right? So it would be -infinity. And you can type in negative, and I don't even think the little text box pops up for me to type that little symbol. I'm curious if I can, no, I can't even copy this. So no, it says just type in infinity. And so that will work. And I do have that as an answer in the answer kit. You have to. If you don't, then it's going to look like positive infinity. And then it won't count it correctly. But good. I'm glad you asked. Okay, here's another one that's pretty visual. And this one says, be sure to explain your answers. So it's asking you if there's a discontinuity. Is there a discontinuity? Where is it at? X equal to 4. You're right. And it says, write the X value of the discontinuity, just the X value, so 4. On your paper, though, why is it a discontinuity? Because it's a whole, exactly. And then it's also asking you, do a comma, then a space, and I did that. Then the word removable or the word non-removable. Which word am I going to write? Removable. And then on your paper, why is it removable? Because it's a whole. So asymptotes are non-removable, right? But holes are removable. Like you can't fix it if it's doing this. You can't just like totally change the direction and make it connect. But for a hole, I could just get a point and fill in the hole, right? So that's why it's removable versus non-removable. Okay? You have to change the whole function to fix an asymptote issue. You don't have to change the function. You could just make it a piecewise function. So here you have a function. This function has a hole. Well, then you just say, oh, well, f of wherever the hole is now going to be whatever the y value is out of the y value. Okay, but now you've built in the hole just by creating a piecewise function. But you can't do that with asymptotes. You have to totally redefine the function. You're changing everything. Okay, I think that's on all of the visual ones. So we still have about 1, 2, 3, 4, 5, 6, 7, about 8 more that are not visual. How would you do this limit? Plug it in. It doesn't give you anything crazy, right? It doesn't give you undefined or anything. If you plug it in, that's going to be 4 plus 4 plus 1, which is what? 9. What's the square root of 9? 3. That's it. There's not too much for that one. What happens if you try to directly substitute this one? You get 0 at the bottom, right? Which means you can't directly substitute. But what can you do to help fix it so that you could substitute? Back to the top and then remove that hole. Okay, I'm gonna go over to the paper. Let's see how great we are at factoring, right? How do you factor the top? X plus 4 and x plus 5, yep, that'll work. And then when these wipe out, you have the limit of what? Just x plus 5, right? Now can you direct sub? And so this one ends up being just 1. Okay, what about this one? Can you directly plug in 0? There's not even a fraction. It's not going to go crazy, right? And sine is a continuous function, so I will get a y value. What is the sign of 0 though? 0. And what's 5 times 0? 0. And then 0 minus 1? -1. So it's not too bad, right? You will probably not have 2 problems that are direct substitution on the actual test. There might just be one that's direct substitution. And then the other ones might require a little bit of manipulation like we did with number 7. What about number 9? Number 9 can actually be done in multiple ways, okay? There's 3 different ways that I think that they showed y'all how to do. One is graphically, one is analytically, which means using algebra properties, and then one is numerically. Okay, so there are 3 different ways to do this. How many of you know how to graph that fraction code? Probably not a lot, right? You know how to graph it? It does. It looks like the 2 little sticks. Yep. And where are those little sticks? At what numbers? You know? No matter what x is, isn't the top and the bottom going to be exactly the same? So the bars are going to be at 1 and -1, right? Because when the top is positive, let's say x was -7. This would still be a positive number, but this one would be a negative number. It's actually at this point. So then when I do a fraction, positive 1 or positive number divided by negative. But if that number was, let's say -4, let's say it was -3, then this would be 1, that would be 1, and I would put positive. Okay, so it does look like this. Here's -4. If I plug in -5 in there, my denominator is going to be negative, so I'd be down here at -1. And it's going this way. And then if I were to plug in, let's say, a positive number, it would be +1, and then it would be going that way. But I don't expect anyone to remember this graph. If you do, fantastic, draw it, that's your explanation, okay? I don't even remember if the problem in the text, but this is the graphic way. Okay, so this is one way to answer it. The algebraic way is never an easy thing to explain, so I'm gonna try. So the algebraic way is to use the knowledge that we know about absolute values, okay? So if x plus 4 is greater than 0, that means it's positive, right? Then when I take the absolute value of it, it's going to be the exact same number, isn't it? If it's positive and I take the absolute value, it's the same darn thing. But if x plus 4 were less than 0, then the absolute value of it would change the sign, wouldn't it? Because it's negative and needs to come out as positive, right? So that means it would be the opposite of whatever this number is. Okay? So then, which one of these am I concerned with? Because it's not both ways, it's just a one way. It's for when X is approaching -4 on the right. Okay, so if I'm approaching -4 on the right, I'm talking about these values, right? Which are smaller or bigger than -4? They're bigger. So even if I took -3 plus 4, okay, what is that going to turn out to be? 1, right? So which scenario do I have? I have the top one where the inside junk is going to be positive, right? Because numbers on the right, when I plug them in there, it turns out positive on the inside, right? So I have this situation, which means that the limit as x approaches -4 from the right is actually equal to just x plus 4 over x plus 4, because that equals that. And then what is it when you get the same thing over itself? Just 1. And what's the limit of any constant? Just that same constant, right? With what? So that's practically, that's algebraically. The one you're probably going to want to do is numerically, not these. That doesn't mean that these are not invalid. These are totally okay. Okay. But numerically is the table. So you have x, you have f of x, and since I'm trying to get to -4, but from the right, I would start with -3, then do, or actually -3.9, right? So that it's like right there. And then get even closer, so -3.99, -3.999. And then you'll notice when you plug those into this expression, if I'm plugging -3.9, what is this? Is it gonna be positive or negative? Right, this number is smaller than that number, right? So I'm gonna get a positive 0.1. Down here, I'm gonna get a 0.1, and they're exactly the same, aren't they? So it's gonna come out to 1. Similarly, I'm not gonna do it for each one, but similarly, the same thing's gonna happen for that one and for that one. And so then what is the limit? 1. Okay, so those are the 3 different techniques. You can do it graphically if you remember how to graph it. You can do it algebraically. I think that one's the hardest. That would not do this one. I just wouldn't. But if you want to, and go for it. And then this one's probably the one I would do, the numerical one. Okay. Just make sure that you're getting values that are right on the other side of whichever way it is. So if it has a plus, you're getting a number right on this side. If it's a minus, get the number right here. Okay. Out of curiosity, what number should I use if it was a minus? If it had said from the left? Negative what? 4.1, and then negative 4.01, and getting closer and closer to that number, right? So what was the answer? 1. Be careful and pay attention to that, because I have a feeling that this one's on there, but I can't remember if it's a plus or minus. I've been creating so many tests this week. I don't even remember which one's which. Okay, what about number 10? Can we plug in that 0 right away? Makes the bottom go crazy, right? This one's unfortunately a little bit more elaborate, right? This one requires algebra. And notice on this one, notice the difference up here. This one just said find the limit, didn't it? All of these, this one said find it algebraically, but you did direct substitution, that is algebraically. This one also said algebraically. Again, direct substitution is algebraically. But this one says also algebraically. So don't try to graph this and then just get the answer from the graph. Don't create a table, because that's a whole nother strategy, not algebraically, right? So make sure that you're doing whatever it says. X plus, or 1 plus x minus 1 over x. Let me see. Limit as x goes to 0, 1 plus x minus 1 over x. Who remembers the strategy to how to get rid of that house? This is the guy I want to cancel, but there's a special technique that you use to somehow make that guy cancel. I see this. Say it again. Rationalize it. Yes, rationalize the numerator, right? So in order to rationalize the numerator, what do you have to multiply by? Fancy words. Conjugate, there you go. So it means the same guy in the front, the same guy in the back, but the opposite side in the middle. So instead, I'm going to use plus. And what I do to the top, I have to do the same thing to the bottom, so I don't just completely change what I have, right? We're manipulating what we have, we're not changing it, okay? We're making it look different, but its value should still be the same. So then let's do our little FOIL stuff. Do not FOIL the bottom because the whole goal is to cancel out that little x. So don't even distribute it in because it's gonna have to come back out to cancel, okay? So just leave the bottom alone. You just write them together and that's it. Now the top though, what do I get when I do this times this? Because you get 1 plus x squared in a house, right? And then the house and the square knock each other out. So you just end up with 1 plus x. What about when I do this multiplication? This focus thing is driving me crazy. Give me one. Not letting me manually fix it. There it goes. Haha. So yes, I get 1 and then the little house, right? What about when I do these two? And then finally, what do I get when I do -1 times +1? -1. And then these are exactly the same thing, so they do cancel. So then I'm left with what? Oh, something else cancels, doesn't it? Don't this guy and this guy cancel? Now I'm gonna rewrite the next step. You may choose not to just because you might already see it. But all I have left on the top is x. I mean, you might have noticed that there's x and x, and since that's the only thing on the top left, it can reduce with this x down here. So you may have went boop, boop, and then just wrote the final answer over here, and that's okay. But for me, I like to write it first and then reduce. And then I'll have 1 and the house plus 1 at the bottom. You don't have to write this down. I'm pretty sure you might just reduce them up there. Can I plug in the 0 now? So I get 1 over 1 plus 0 plus 1. What is the square root of 1? 1. And so then I get 1 over 2. Now let's go check at those directions because I don't know how they want me to write the answer. Oh, it doesn't say. So I can type in 1/2, 1 over 2. I can type in 0.5, or I can type in 0.5. It should accept all of those. They're all the same. What about this one? Does it not exist? You cannot simplify it any further, but how do you know that the limit does not exist versus it being positive infinity or negative infinity? Say it again. It does, but that doesn't mean that it does not exist. It could be positive infinity or it could be negative infinity. When your denominator is going to 0, what's happening is, let me write it on the board. This is just number logic, okay? If my denominator is 1, my denominator is 2, this is 0.5. If my denominator is 3, this is 0.3 with 2, right? What's happening to the value of the fraction as the denominator gets bigger? It's getting smaller and smaller and smaller. It never goes negative if you move this bigger and bigger, right? But it does get smaller and smaller. More importantly, it gets closer and closer and closer to infinity, right? So when you have a number in your numerator, and then you have this denominator, if the denominator is going to infinity, then the whole thing will get smaller and smaller and eventually goes to 0. Okay. Whereas the other way around, if your denominator is going to 0, what's going to happen to the fraction? Well, now I'm going in the other direction. I have a large denominator. That's my result. This is my result. This is my result. What happens if I keep getting smaller? What do you get when you do this? You get 2. What do you get when you do this? It's still smaller, right? The reciprocal of 1/3, 3/1, right? You get 3. So as my denominator gets smaller and smaller, what's happening to the value? It's getting bigger and bigger and bigger. So eventually, if I do this, it's going to be 1, 2, 3, 4. 1, 2, 3, 4. Okay. So as the denominator gets tinier, it goes to 0. It actually goes to infinity. However, that's if I was on one side only. But I'm not looking at just one side of -2. I'm looking at both sides of -2. Okay. So the only way to do this problem is not going to be algebraically or logically. There's only 2 ways that you will actually get an answer. And that is one, to do it graphically so that you can visually see it, or numerically so that you know what's happening on both ends as you plug in those values. Okay. So for this one, you cannot just talk it out logically. You won't know what it's going to do. Okay. Now I know that personally I would graph it just because I know how to graph rational functions. I know that 1/x looks like this. And if you add something to it, all it does is shift it left 2 units. So then I know instead of it doing this weird business around 0, it'll actually do that weird business around -2. So graphically, is there a limit? No, because this one's going upward, right? And then this one's going downward, okay? That's just me, that's my way, okay? Because I can do it really fast. But if this does not come to you through the chart, okay? All you have to do is when you set up your chart, make sure you're going in both directions, right? So you have x, you have f of x, and then if I'm talking about to the left, this is -2, I'm going to be -2.1, -2.01, and so forth. I don't ever do more than 3 because I'm pretty sure you can figure out what's going on after 3. Sometimes even 2. And then on this side of -2 is actually -1.9. -1.99, and then -1.999. And then eventually it should be able to tell me what's going on at -2. Okay, yes. No. Right? Incorrect. There's no limit here. If the graph happens to look like this, the limit is positive infinity. And it has an asymptote, doesn't it? But the limit does not exist. The limit is positive infinity. Or if the graph looks like this, it's negative infinity, does not exist. So that's why that explanation doesn't fly. Okay. So what was mine? Because mine was like that one, right? Ours was B and E for this. And somebody had a great observation. They already knew, somebody said it the last time, but they didn't make this conclusion, but I'm gonna make it for you, okay? If what you have downstairs has all odd powers, okay, and on the edge. But if this guy has an odd exponent, then it's going to do this, okay? I don't know if they're gonna go like that, or if they're gonna be on the other side doing this. It doesn't matter. They're gonna be going one direction and the other, okay? But if this little guy has an even exponent, it's squared, which means it'll always be positive, right? And so they'll either both be going up, or depending on that number and that number, they might both be going down, okay? So you can kind of make some inferences with those exponents, but eventually you're graphing it, okay? Okay, what about this one? Is it, if I'm on the right side of -7, then I am less than -7, right? Or am I greater than -7? Here's -7, if I'm on the right side, I'm greater than -7, right? So when I add 7 to a number bigger than -7, what is it gonna come out to, positive or negative? Plug in any number to the right of -7, say -8. Or not -8, -8's on the wrong side. Who's over here on this side? -6, yeah. And you plug in -6, you get positive. So you can tell me which direction it's going in and what the thing is just by using your logic there, okay? Essentially what you're doing is the table just not plugging in so many numbers. You just plugged in one number and you figured it out. But we do know based on the other one, it's gonna look like this exact same thing, except the asymptote is at what number? At 7. But other than that, it looks exactly the same. And so you see on the right of 7, it goes up, doesn't it? So I would type in infinity. If you write plus infinity, it does mark it wrong. Because in there, I only have the word infinity for infinity, positive infinity. But if you did do that, I would go back in and give you most of the points. So if this were like a 10-point problem and you put a plus infinity, I would probably give you like 9.5 points because you knew what was going on. You just didn't listen to the directions where it says, if it's positive infinity, type in this, okay? Oh, our favorite one, right? The one with the video. Last one, last one. So does anybody remember the strategy here? Say again. We got to use that. It's multiplied. You multiply by what? Why are we multiplying by 5/5? We're trying to get this and this to be the same. Yes, exactly. Okay. So I need a 5 down here because there's a 5 in there, right? But whatever you introduce to the bottom, you have to do the same thing to the top. Okay. We can just conveniently choose, because of the properties of limits, that if I'm multiplying by a constant, I could just write that top constant in the front. So it'd just be 5, limit as x goes to 0. And then I could conveniently choose to put these two together at the bottom. And so then it says 5x. Now, someone did ask me, this was not in this class, it was an online class, but someone asked me, aren't these all supposed to match the property? Not necessarily. They have to do the same thing. They don't have to look the same. So think about this. If you're saying as u goes to 0, that means this inside is going to 0 and that down there is going to 0. Okay? And as long as that's happening, it will turn out equal 1. Now here, I don't have 5x is going to 0. I just have x is going to 0. So what happens to this as x is going to 0? Isn't it still going to 0? And the same thing inside there, right? So you still have the same action happening, which is why you still get 1. Okay. It doesn't have to have a 5x right there. But this big thing just becomes a big fat 1, which means my answer is what? Is 5. Be careful because I really think that there is a problem similar to this one in the test. However, I don't think that it just has a 5 there. It either doesn't have a number there and only has a number here, or it has a number in both. Okay, I don't think that it's exactly like this. But if, regardless of those the way we get all of them at exactly the time, you still use the same property. I think we've finished the review, haven't we? Oh yeah. For this one first. Yeah, I think that's the end of it. Does anybody have any questions? You can find similar problems to these using if you wanted, or look back in the homeworks. The only ones you won't have problems for in the homeworks is the intermediate value theorem and the proof. There's questions like that in the textbook, like toward the end of the sections, but not in the homework. And I think all of our homework assignments have already been due, so you just need to work on this. And if you were working along me, you might have already had all the answers, right? Yeah.
Yeah. I know the mistake of not listening to this. The other problems.
Why would I do that? Okay. Yeah. Oh, you're in the middle of it. Yeah. Oh,
Pretty easy, you should just like do it now. No. He said you're- No, she's good. She just has that there. Well, no, the entire answer there is the actual. So yeah, you do have to. The other one stuff.
okay, you guys, if you don't have any more questions for me and you don't have any more homework to do, already done with the review, you guys are free to go. I am gonna still be here just because I have to be available. If you come up with anything, you can definitely ask me. Okay. Other than that, use the rest of class time as you want. Okay? You are also free to go if you need to go somewhere. Okay, let me find my web assign. I will send out a remind text too, but if anybody's wanting to take the test online, you do need to let me know so that I can make it available for you online. Otherwise, just show up to class and I'll give you the paper. Yeah, you should be able to review the test.
Or like so basically, -4 is less than the
Crossword.
but -3 is greater. That means you have the solution to -4 is less than 0. And the solution to -3 is greater than 0. You have at least one solution that fits the interval of -4.
Don't know. Say it again. Yeah.
Those are on and you have
As soon as I finish it here, I'll go back and then so you can see it. I think I already did. Oh. Dun, 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 dun. Do you have your phone? Here you go. That's the first one. The next one? Okay, this one. I'll scoot it over as soon as you take a photo. Got that one? Okay, there. Okay. Mm-hmm. For what? Well, how are you going to take the test? Are you going to take it in class? Or are you thinking of taking it online? If you take it in class and you just write it down on a paper, you're not gonna have to type anything in. It's only if you do it on the computer, and if you opt to do that, then you'll have to type it in and then upload your work. Why is this thing not working? It says that that's my account. Oh, no.
Oh, yeah. You wrote them down on the day. Yeah. So I said I'm doing it. Because I was at yeah, I do.
Oh, I know what I'm doing.
So is the limit is the y value at which function either approaches or
Just approach it.
just approaches.
Just approach it.
But it sometimes it does not.
Correct. Sometimes the point is defined somewhere else, a different y value. Mhm. 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 That's okay.
Is it okay if I erase it?
Yeah, you can erase all of it.
I do get confused.
You too, bye-bye.
Let's say you have a graph. Like this. There's a hole right here. Hole right here. It's at x equals negative 2. But then you have. Then you have a dot point right on top of that. Another y value. This is another y value. But they're both at the same x value. And the function, you know, what I imagine the function goes on.
That is the actual y value. This one is the limit of it as a function.
So this, even though there are 2 points where x is approaching different
X
y
is
values.
not approaching it, they're approaching around it.
Okay, there you go. So this is not this. So
Correct.
it's not equal this, right?
Right.
So this is its own separate thing.
Right.
And this is,
Exactly.
okay, that's
Yes,
where the confusion starts. Because I believe
Or like
presume
y is y value, yeah.
that this is part of the function.
It is part of the function, but it's a piece by function. So you have your main part of your function, and then you have this extra.
So algebraically, I'm saying, like,
I would have to know what this is.
yeah, right. Right, that's it.
I
It's
would have
good.
to know. But there's a difference between where the function is defined and where the function is approaching.
Oh,
And here I am approaching it, but that's where it's actually defined. And it's only continuous if these two things are actually the.
oh,
So if that one were actually right there, then they would match and it would continue.
so this is this. So this graph has a limit. It has a limit. But it's not continuous.
Correct. Because the other guy's way.
Okay. And then, like we said, f of -2 is not equal to the limit of f of x, because it is part of f of x, but it's not what is approaching. So it's not
It's not the same y value as what it's approaching.
approaching. Yeah. Okay. Now I understand a lot better. That was what was tripping me up the most in this class.
Gotcha. Good, good. Showing on there, right?
And then also the sign of x over there. But I see. When I watched you do this, actually really easy, 'cause I don't know about you, but I love the unit circle.
Oh, yeah, yeah.
It's so fun.
And it was using all those values, like for the height and the width.
It was using Pythagoras,
Yeah.
and then it was a bunch of geometry.
Right.
It was also used my free calculus. Believe it or not, there's free kind of lot to do with geometry.
Oh, yes, Jonah, there you are. Say it again. That's when we're having the test is on Tuesday. Uh-huh. So if you're gonna do the paper version of the test, just show it to class that day. But if you're gonna do the test online, then let me know beforehand. Okay. I'm gonna send out a remind text so I can get a tally of who's gonna do it. It was 2.5, right? Was the one? Yes. Oh, because of all those little spots, that's why the grade went down. Number. This one. How the heck do I edit the down? Override, there we go. How many? That's 8 pieces. Save. Yay, now it says 30. It still has them with the next, but then it has my extra points today. Okay. Like, I don't know, I don't think so, but I don't know for sure. But if it is, make sure you do 1 over kind of. Yeah, but I don't think so. Sure, you have to go in.